Thank you very much for the kind introductions. Ladies and gentlemen, I'm working as a full-time NMR spectroscopist in a Hungarian-based pharmaceutical company, Gedeon Richter. We are a specialty meat pharma company, and the company has more than 10,000 employees worldwide and more than 2 billion euros revenue. And the pharmaceutical company was founded by Gedeon Richter more than 120 years ago. Our company focuses on four business branches, including neuropsychiatry, women's health, biotechnology, and general medicines. As we are a vertically integrated pharmaceutical company, structural elucidation related questions come from a very wide range of pharmaceutical units. The main categories are, for example, medicinal chemistry related structural elucidation, where many small molecules are synthesized in very small amounts. And the main challenge is the very stringent deadlines which has to be met. So each structure verification should be done very quickly, but also with high structural confidence, which are two contradictory demands in general, but both of them has to be met. Another main structural elucidation task relate to the scale up or the synthesis of promising compounds, which has to be synthesized in larger amounts, for example, for toxicological or clinical trials. And for these synthesis, before going to production scale, the reactions, the reactivity of each intermediate and the impurity profile of them are studied thoroughly. For example, sometimes we have as challenging task as to elucidate some impurities in the API or the intermediate at the level of 0.1%. Our third main category of structural elucidation tasks relates to publication related reporting. We are processing several thousand samples per year, mainly by NMR spectroscopy and mass spec, but some samples are also analyzed with infrared spectroscopy or circular dichroism. And we also participate as a whole spectroscopic team in multidisciplinary, high-stakes, highly complex projects which require the use of state-of-the-art spectroscopic techniques, including, for example, 800 megahertz NMR spectrometer. So our structural elucidation team has been using ACDLabs products for decades, mainly started with NMR workbook. And as our invaluable data set begin to grow, we decided to organize them into a more structured database and workflow, which was implemented by ACDLabs professionals more than a decade ago. I would like to introduce that workflow in brief and some recent developments to it. the majority of our samples are made by synthetic chemists working on medicinal chemistry projects who use their own electronic laboratory notebook and submit their sample via a file exchange service, which was implemented by ACDLabs professionals. It's a SpectrosDB enterprise service which processes these submitted samples into our database. And in the next step, we wait for the sample submitted to us to arrive physically. Then we check in those samples in the database. In this process, a unique spectroscopic ID is given to the samples. Then this sample is ready to be measured via different spectroscopic techniques. After these spectra are measured, they are processed by automation servers, mainly copying of those spectra to a archive folder and databasing it to a centralized SpectrosDB enterprise server. The data of the instrument are processed by the analyst, mainly in NMR workbooks or other similar software. These analyzed data are discussed then in our spectroscopic team, and if each techniques analyzed agree with each other, then the final results is approved in the database. Finally, the SpectrosDB enterprise server creates a PDF report and sends the result to the sample submitter via email. Our recent development is related to the communication between analysts and technicians about which parameters should be set during the measurements, which kind of spectra should be measured using which of the available instrument. And the other topic covered today is about some human-made obstacles or in the working of automation servers, some errors that should be circumvented. Both topics, interestingly, relate somehow to the use of paper or the process of going paperless. We used to have to use paper for a long time due to GMP reasons. So this is a template of our spectroscopic system, the sample data management system. You can see some details here. The main point is that for a long time, we had to sign and print every piece of digital data due to early GMP regulations. But some of the developments we went through in our company could relieve us, and now in the company the use of paper is not obligatory due to new GMP regulations. So our spectroscopic laboratory tried to went through a paper elimination process in the workflow. However, it was a little bit challenging because we were used to some nice functions of the paper besides the GMP regulations. For example, we noted the measure the spectra, the exact parameters, and we just handed the paper to our technicians who could process these settings for the measurements easily, just reading them from the paper. Therefore, to facilitate or to build an alternative possibility for communicating the measurement parameters from analysts to technicians, I developed some ACD forms in the analytical workbooks software, which is basically a Spectroscopic DP viewer and editor platform. In this screen form, we can add a database filter tree views, for example, which is a very nice function because it can filter for sample details in the database and show just those samples for which we have requested some NMR measurements to the technicians. To insert those measurement parameters, I had created some pop-up forms on which we could add which instrument, which solvent we want to choose, some measurement we can choose, and additional comments to the technicians. Actually, the CAM analytical workbook process these forms like that some new user data fields are added to the database for that particular sample. And this data can be then queried with the leftmost view, and all of them of the relevant samples can be exported to ChemSketch or PDF, which can be viewed by everyone in the laboratory. So we can use that PDF to set up the measurements at the instrument easily. When measurements are done in the past, it was very clear to us analysts because the signed and printed spectra were just placed by our technicians on our office desks. So we knew the exact point when we had to start to analyze the spectra of that particular sample. But once paper has been eliminated and spectra are not printed anymore, we only have the options to search for spectra of a particular sample in the database. And I will talk about a trick which can happen about finding those spectra in the database. Actually, the NMR spectra measured by us are detected by automation servers set up by ACD professionals, which can scan the entire folder system or the instrument computers, and using the rules given by the spectrometer manufacturer and its related folder structure, automation servers can detect new NMR spectra. They can also filter out the other spectra which had been processed already. So the automation server can gather a list of new spectra which should be processed at that moment. For example, on Bruker NMR systems, we have such complex folder system The main point is it has a name tag which decodes the sample ID or include them. So these spectra are found by the automation servers, and they are first copied to a network archive folder in our setting. And then these spectra are also databased into the Spectroscopic enterprise server. But it has a logic to find the corresponding database entry for a sample with the corresponding measured spectrum name. So databasing is only done when sample ID in the database match exactly the sample ID in the name tag of the measurement directory, which can be seen in red. But it is a very common and tricky error of mistyping the sample folder. For example, as you can see, there is a hyphen accidentally added in the PMMA gel. Actually, in the database, we have a sample ID without a hyphen. And actually, in this case, automation server does not process the NMR spectra because it was given the command that only exact match of sample ID should be processed. In the end, in the database, we won't see any spectra appearing. So it can be a little bit misleading, and we can think of that this sample is in the measurement queue, has not been measured yet. So the workflow stops here and may cause analysis delays, which has to be circumvented somehow. In my development process, I learned the details of how ACDLabs products work, and also the Spectroscopic enterprise database, how is it built up. So with those knowledge, I could solve this mistype folder problem in the end. So I will discuss that solution briefly, but the following slide will be a little bit too technical. I just want to show the value of learning about the details of the ACD products system and how can we leverage even more performance or success from that knowledge. So let me introduce my solution briefly. First of all, I started to scan the instruments file system to find all recently measured spectra to then filter which of them are corresponding to mistyped folder names. Then I learned some SQL queries and processed them through the ACDLabs Spectrosdb, and particularly the user data table, which are storing the sample IDs I needed for cross-filtering. So actually, in the Chem Analytical workbook, you can see some sample data, user data as a field name like reaction image and its value pair. In the database, it is stored a little bit differently. Interestingly, even if you have several thousand of samples, all of them are actually stored in a single table user data table. And in this database table, one row corresponds to one field name value pair in the view you can see in the Chem Analytical workbook. And the desktop client software actually is sorting and filtering them with by this root project ID, and also substituting the user data names IDs with actual values from a different database table. So in a database of table of several thousands of samples, they are filtered with this ID you can see in the left bottom corner of the software. And the values are actually stored as text value fields. The main point of this logic is that it's very complicated to analyze data from the ACD labs database. So for example, we cannot query this kind of raw data into a table directly, because the columns are also stored as rows basically. So to generate table view, which is very useful for viewing the data from this kind of database entries, it cannot be done directly. It needs a very complex procedure called data pivoting. But my task was to filter for sample IDs a single kind of data in the database, which could simplify the SQL analysis and query for my task. I just had to find the sample IDs corresponding ID number for this UDN ID, and then only query for that value with a simple SQL statement. Then I could get a list of sample IDs in the database with my Python script, and I can cross-filter those sample IDs to detect the folder names of NMR instruments which are not included in the sample ID database. So in the end, I got a full list of mistyped folder names, and I just need to detect those measurements and correct those folder names manually, just a few of them, or in the spectrometer directory. So with that kind of solution, I managed to quickly resolve workflow stops due to mistyped folder names, which correspond to measurement data which are not processed by automation servers. And by doing this, I could enhance the workflow of our spectroscopic service and decrease delays introduced by paper elimination. I have to notice something about learning the database of ACD system. I just want to note that if you are doing SQL statement with direct access of the Spectroscopic please only use select queries which retrieve data and never try to modify anything in the database because there are many very complicated interconnecting tables and it is easy to make error in the database. So just please leave those complicated procedures to ACDLab professionals. So to conclude that, today I talked about our spectroscopic laboratory of Gedeon Richter and how its workflow is implemented by Spectroscopic platform. And I also introduced briefly that we were trying to go paperless in our department, and it was it was indeed a successful transform, but some tricks happened, and to resolve those tricks, we were required to introduce new solutions which are working well today. And my take-home message is it is very useful to learn the details of the ACDLabs working, and it is also very useful to learn some IT databasing and programming skills for a spectroscopist. And thank you very much for your attention, and I'm looking forward to answering your questions.